So graphing an inequality, linear inequality, in mx plus b form. There are a few options for us. Focus first of all on this y is greater than. If we have greater than, we have a couple of options. Y greater than is shading above. Y greater than or equal to is also shade above. And then we'll learn we have y is less than or equal to. They both are shade below. Shade below. But then there's one big difference between having a less than but not equal to. When you have less than or not equal to, it is a dotted shading or dotted line with shading above. If it is a less than or equal to, anytime you have the equal to, you have a solid line that's shaded above. And then down here, if you have the less than but not equal to, it is a dotted line with shading below. And if it is a less than or equal to, it is got a solid line here. You put a solid line with shading below. Those are our four options for shading after we've already plotted our line. So now we're going to get into the business of actually plotting our line. So we start by identifying the y-intercept as the b value. So I'm going to plot a dot at -1, and then I'm going to use the slope to rise -2, which actually looks like going down 1, 2, and then running 1. So that should be my second dot right there. So now I'm actually going to click that here. So I'm going to click a dot at -1, and then I'm going to go down 1, 2, right 1, and click a dot. First thing I need to think about is the fact that this is not supposed to be a solid line, because I said just a moment ago that this y greater than needs to be a context where I have a dashed line with shading above. So I need to click change line. So I click change line, and it turns to be dashed. If I made a mistake, I could change it back. But I do want it to be dashed, so I leave it as dashed. Now, I want the shading to be above. Well, I need to figure out where above would be. Above, this is above. This is below. Very simple, right? We've got above needs the shading to go to the direction where the word above is. So we go ahead and click change shade, and there will be shading either above or shading below. I want the shading to be above. This will be the right answer with the solution set shaded. The solution set means that all of these dots over here, everything that's shaded, any coordinate, any spot that I pick, like this dot, 8, 6. That coordinate 8, 6, I could plug in here and it would make a truth statement. So 8, 6, if I plugged it in, where the y is set to be greater than -2x minus 1, if I plugged in the 6 for the y and the 8 for the x, this will be a true statement. 6 is bigger than -2 times 8 minus 1. Every coordinate that's plotted over here in the shaded region makes a truth statement. If you're on the line, it would not make a truth statement because it would be equivalent, and this does not include equivalencies. So let's try another one. So this time, we're presented a problem that's in standard form. And now using my 4 steps that I wrote on the last one, y greater than or equal to, y less than or equal to, what I want to do is make it look like these so that I can use my shading descriptions from that previous example. So I'm going to manipulate this to get it simply into slope-intercept form. I do that in 2 steps. I take this -4x and add it to the other side. So I can treat this equivalency sign that less than symbol to be just like an equal sign as far as it plays with my equation solving. So I go ahead and make this 4y is less than, and make sure that you put the 4x before the 35 to put it in mx plus b form. So plus 4x plus 35. And now I want to finish by dividing by 4. 5y. I apologize. Divide everything by 5. And then, once I divide everything by 5, because that was a 5, I get y less than 4/5 x plus 7. And so I can plot using slope-intercept form, starting at 7, and then I want to rise 4, run 5. Now, rising 4 is going to be an issue here, because if I'm starting at 7, I can't rise 4 if my graph stops at 10. So rather than rise 4 and run 5, I can go down 4, left 5, and have the same effect. So I can go down 1, 2, 3, 4, left 1, 2, 3, 4, 5. And this is the same. So going down 4, left 5 is the same as going up 4, right 5. These will have the same slope. Now, I'm going to go ahead and connect those on the generator here by clicking at 7 and then bringing it down 4, left 5. And you can count from there and rise 4 and run 5 and double check your slope to make sure it is correct. But this is the right thing. So this is the right spot for my line. Now the question is what's my shading supposed to do? Well, because this is the situation where we are less than, it is not equal. So I'm supposed to have this one right here, which was going to be a dashed line, and it's shaded below. So I click change line to be dashed. I change shading. That's above shading. This is where shading is above because it's heading toward that top where I wrote above last time. This is above. I need it to shade below. You should be reaching toward the bottom arrow of the Y axis to be shading below. So I click change shade one more time. Now this is done correctly. I have shaded below with a dashed line. That is the correct solution set, shaded. Every coordinate in here, the coordinate 0, 0, 6, 0, 6, -6, all of these coordinates work as solutions to this inequality statement above. Let's do another one. And in this third example, what we have is another standard form expression, but this time we're going to have a negative division. Anytime, it's just a background rule, anytime you divide or multiply by a negative for an inequality, the inequality flips. Oops, I was supposed to say flips. So here's how I try to sync that in. Well, I'll show you the first step here is you got to move the 3x to the other side. And then we have negative 4y is less than, I'm going to put the negative 3x first, plus 4. And then what I like to do is I like to call these inequality symbols alligators because that's what my kindergarten or first grade teacher called them. And it just stuck with me. And so I'm going to draw the alligator for you for effect. Because what's going to happen is when we divide by a negative 4, what you're doing is you're grabbing the alligator's tail. And if you think about it for just half a second, if you grabbed an alligator's tail, what's he going to do? He's going to turn around and bite you. I know, it's kind of silly. But the alligator turns around to bite you, just like that. And so when I divide everything by -4, this gives me y is now the alligator's turned around the other way. And this reduces to be 3/4 x plus, well, it's going to be -1 because 4 divided by -4 is -1. So it will be wrong, though, if you do not flip the inequality symbol. So it just switches direction. It literally turns around. It's like you poked an alligator and you turn around and tried to bite you. And then we go ahead and plot using slope-intercept form. Start at -1, and then we rise 3, 1, 2, 3, run 1, 2, 3, 4, and get this coordinate right there. So we're going to click right here, -1, rise 3, run 4. And then just like before, we have to check what situation we have for the context of our line. This is greater than. Greater than does not have an equal sign, so I'm supposed to have change the line to be dashed. And then this is shade above, so I want my shading to be above, just like this. This is the correct shading for this problem. Let's take a look at one more inequality. This time, we still have the negative on the y, which is going to have that alligator situation where it's going to turn around. And then, difference here this time, we have a solid inequality. So what we want to do is move the 3x by subtracting it to the other side. I'm going to put it in my slope-intercept form so that I can judge with my y greater than, less than scenarios as discussed before. So I'm going to subtract my 3y, and I have now -2y is greater than or equal to -3x. I don't know why that turned into a y. Plus 2. Then, when I divide by the -2, just like the last time, it's a little bit different though. It's not as cute because it doesn't look like an alligator here because the alligator's teeth are on that side. I get it. But still, this is the tail. I know it's kind of, my analogy doesn't work perfectly from the previous example. That's okay. When you divide by the -2, keep in mind you just poke the alligator in the tail. And so when I write the next level here, this inequality needs to turn around. So now it's facing the other direction. Now, I have some students that they drop the equal sign because they think it turns and drops or whatever. It just switches direction. When I say flip, I just mean turn around. So this is y now less than, so it's positive y, less than or equal to this time. And then we've got 3/2 because the negative divided by the negative, it'll be 3/2x and then -1. So our job will be to plot. So I go to -1, rise 1, 2, 3, run 2. Right here will be the dot. And then how I connect them, since it's y less than or equal to, this is the shade below, because less than is below, and then it's got a solid line. So we're going to have a solid line with shading below is the solution, is how we get the solution set. So remember, this is where our above is. This is where the below will be. And so I want the shading to be down in the lower region. So I click my dot, -1, rise 3, run 2, click it in there. And then I click change line. And that would be a mistake because I need a solid line. So I change it back. And then I need my shading. Shading above would be incorrect. So I click it one more time, shade below. This is now the correct solution set for a context with a solid inequality, which is less than or equal to. Now the difference is, why this is meaningful, is all these coordinates are solutions out here in the shaded region. But also this time, any dot on the line, if I was to plug in this dot right here of 2, 2, 2 into my inequality up here, it would create a truest statement where the left side will be 2 and the right side will be 2. 2 equal to 2 makes a truth statement, and that's what we're looking for with inequalities.